Number 9, rationalize the denominator. Let's take a look at part A. First of all, a rationalize the denominator means that your denominator has a radical and we want it to be radical free. So in order to do that, we need to multiply it by appropriate number or the quotient in order for the denominator to be radical free. So in order to do that, we're going to multiply it by radical 7 over radical 7. And remember, we only care about the denominator being radical free. We're not really concerned about the numerator being radical free. We care more about the denominator being rationalized, meaning denominator having no radicals. So in the numerator, we have 5 times 7, which is 35. And the denominator 7 times 7 is 49. And we know what radical 49 is. Square root of 49 is 7. So radical 35 divided by 7. This is actually our final answer. Now if you're thinking, oh, can we reduce it a little bit more? Can't we do this where we cancel and cancel? But hold on, we can't do that. The reason why is because this is a radical term. This is outside the radical. They're in different families. So you cannot cancel out something that's outside with something that's inside. These are two different things. Now, if I give you a question that was radical 35 over radical 7, of course, yes. Then you can cancel and make this 5. But we're not allowed to do that if it looks like this. 7 is outside the radical. 35 is inside the radical. They're not in the same situation. So you can't reduce it any further than that. So leave it at that. Next up in part B, we have to multiply by a certain fraction. And this fraction is going to be consisting of a cube root, because clearly for a denominator we have a cube root. But you have to be strategic about this. If you write that this is x squared and x squared, you're going to already get the whole thing incorrect. You're going to get no points for that. So what you want to think about is how many more extra x's do I need so I can do a group of 3. So let's say that you do 2 of these x's. Wouldn't you have too much? 2 here, 2 here. You have 4 x's. Am I going to group everything? Is everything going to get outside the radical? And no, it's not. Just something is still going to be stuck inside the radical. So it's not okay to multiply by x squared. So if you have 2 here, you need a total of 3. How many more extra x's do we need if you already have 2? We only need 1 more. So only 1 more x, only 1 more x. So that's how we're going to start this off. 11 cube root of x1 cube root of, and remember 2 here, 1 here, total 3 inside the radical. From here, if you already know the denominator is x, just go ahead and write x and you're done. But for the rest of us, I'm going to do this the long way, where I'm going to write out x times x times x for the denominator portion. You can see the x cubed, I just wrote it as x times x times x. And notice here, I can group a group of 3, which is now x. This is your final answer. Part C. In part C, we are going to do a very similar thing where we're going to multiply by a quotient with a 4th root involved. But notice here we only have 1 x, so only 1 of these x's, and 3 of these y's. So you have to think to yourself, how many more x's do I need so I have a full total of 4? How many more y's do I need? I already have 3, so I have a full total of 4 y's. So hopefully for the x's, you need 3 more x's. For the y's, you need just 1 more y. Because remember, you already have 1 x here, you just need 3 more, so you get a complete set of 4. You already have 3 y's here, you just need 1 more, so you have a complete set of 4 y's. In the numerator, just copy that down. So here, we're going to write 7, 4th root of x cubed y1. In the denominator, 1x here, 3 x's there, 1 plus 3 is 4 x's total. 3 y's here, 1 y there, 3 plus 1, that's 4 y's total. So if you already know the denominator is xy, just go ahead and just write xy. But for the rest of us, let's actually write it all out. So I'm going to write all the x's, I'm going to write all the y's. And so what I just did right now was I just changed this x to the 4th, y to the 4th in its factor. Here we're going to group a group of x's and a group of y's. And this is going to be x, y for the denominator. This is my final answer for part C. Let's take a look at part D. In part D, we have a fifth root. So we're going to get ready with writing fifth root. Now again, just like before, we have 2 x's, 1 y, 3 z's. So you have to think to yourself, how many more extra x's do I need? So I have a total set of 5. You need 3 more x's. What about this one for the y? You already have 1. How many more extra do I need? So I have a total set of 5. You need 4 more. Lastly, we have z to the 3. How many more z's do I need? So I have a complete set of 5 z's. You need 2 more. The numerator, just copy and paste. So here we have 11 and the same radical. And then the denominator, if you already know that your denominator is xyz, just go ahead and write xyz. But I'm going to write that there's 2 x's here, 3 x's there, 2 plus 3, that's total 5. 1 y here, 4 y here, 1 plus 4 is 5, total y is 5. 3 z's here, 2 z's here, 3 plus 2 is 5, total z is 5. Now your denominator is easily, if you already know it's xyz, just go ahead and write xyz. But for the rest of us, I'm going to write this all out as 11, fifth root of x cubed y fourth z 2. But for the denominator, I'm going to literally write out all the x's, all the y's, all the z's. When you do this, you can group a group of x's, a group of y's, and a group of z's. So everything leaves the radical, basically. So that will be x, y, and z. And this finishes off letter D. Let's take a look at letter E. So letter E, we're going to multiply by the conjugate. So in order to do this, this is different from any other problem that we're doing because this is the first time we have a sum or a difference in the denominator. So notice here, one thing in the denominator, one thing in the denominator, but here, 2 things in the denominator. Here, 2 terms in the denominator. So in part E, since we have 2 terms, we have to use a conjugate. Conjugate is just writing 3 and radical 2, but changing the sign in the middle to a plus sign. Copy it down and copy and paste for the numerator part. From here, we're going to get ready by writing little parentheses everywhere, so we get ready for foiling action that's about to come up. So let's go ahead and FOIL. 6 times 3 is 18. 6 times radical 2 is 6 radical 2. 3 times 3 is 9. 3 times positive radical 2 is positive 3 radical 2. Negative radical 2 times 3 is negative 3 radical 2. Negative radical 2 times positive radical 2 is negative radical 4. From here, you could actually do a little bit of simplification. These 2 terms here cancel completely. So let's go ahead and cancel and cancel. And another thing that we know is that this is the same thing as 2. So just keep that in mind. So in the numerator, we have 18 plus 6 rad 2. In the denominator, 9 minus 2. So all we have to do right now is actually just fix the denominator. 9 minus 2 is 7. This is your final answer. Let's take a look at part F. So again, we have 2 terms. If you have 2 terms here, and how you know you have 2 terms is if you have something separated with a plus or a minus. That's the differentiation between one term and another. So we have to use the conjugates here because we have 2 terms. We're going to multiply by the same denominator, but the conjugate version. So instead of writing plus, we're going to write minus. Copy and paste for the numerator. And now we're going to distribute the numerator, distribute the denominator. So let's do the first thing. 7 times 5 is 35. 7 times negative radical 3 is negative 7 radical 3. We're on to the denominator portion now. 5 times 5 is 25. 5 times negative radical 3 is negative 5 radical 3. Radical 3 times 5 is positive 5 radical 3. Finally, positive radical 3 times negative radical 3 is negative radical 9. Notice these two middle terms, they do cancel out very nicely. Another thing we should notice is radical 9 is a nice little 3. Numerator, just copy it down as is. The denominator is 25 minus 3. So numerator, just copy it down as it is. Your denominator, brand new denominator, more simplified, is 22. This is your final answer. And that completes number 9.